an initiative by RISE that is a part of the Gopali Youth Welfare Society. I am Yashaswini, a senior executive member at RISE, and I will be holding today's workshop on AI and ML. I think you have had, most of you have attended the previous two sessions. So the topic for today is natural language processing. So the agenda will be somewhat like this. First, we will understand what NLP is. Then we will see some real life applications of NLP. We will see where it is used in our real life, and you will find out how most of you use NLP daily without even realizing it. Next, we will go under the hood and see how the applications of NLP work. And finally, we'll talk about the future of NLP. Alright, so NLP is natural language processing. So let me start by introducing what is actually meant by NLP or natural language processing. Basically, through NLP, which is a branch of artificial intelligence, we give computers the ability to understand text and spoken words in the same way human beings can. This in turn helps humans and computers interact better using common language, common human understandable language. So now I'd like some of you to answer whether you have ever talked to a computer. Have any of you talked to a computer?
Yes, ma'am. Ma'am, when we use any programming language, we talk to computer only as we talk to computer in their language. So our language and their language is somewhat not similar.
Absolutely correct. So when you talk to a computer using a programming language, the language is somewhat different than what our language is. But now my question is whether you have talked to a computer in your own language. I give you a hint, somewhat like a chat bot or something similar. Anyone?
Yes, ma'am. By Cortana.
Ma'am, like Google Home and Alexa, we have these
Yes,
two
ma'am.
things which we
Ma'am,
whom we
Siri.
talk to.
We talk to
Of
Alexa.
course.
Ma'am, like Alexa, Siri,
Ma'am,
Cortana,
Google
Google
Assistant.
Assistant.
Like Google Assistant and all these things.
Yes, ma'am.
Absolutely, absolutely correct. So we talked to these things that you talked about, Google Assistant, Siri, Alexa, using common language, like we talk to our friends, right? Not exactly to a machine, as what we do while programming, writing syntax, that is different. So NLP, what it helps us to do is talk to a computer very naturally, like it's our friend. All right. So I think you have got a brief idea about what NLP is. Okay, moving on. I'll give you a text on your screen. It will be visible to you right now. So I'd like you all to take some time to read this text, okay, and summarize it. First, what you have to do is give a title to this paragraph and then write a few points of this paragraph, summarize it. All right, take some time to do this. I'll continue in 2 minutes or a minute. Yeah. You can all lower your hands right now. And once you are done summarizing it, please raise your hands again. I'd like you all to lower your hands right now. Okay, so 1 minute is done. So are most of you done with it? Please raise your hands. If you need some more time, it's fine. I can pause. Okay, so I can see about 17 hands raised, 19 hands raised. So I'm assuming all of you are done summarizing this particular paragraph, right? Okay, 29. All right, this is increasing. Okay, great. Let me pause for a few more seconds and we'll continue. Okay, great. Great, great, great. Amazing. Okay. Okay. So let's continue. Now, this is how the computer understands text. Here, okay. So I'd like you all to unmute and tell me, what did you write? I told you all to give a title to this passage. So how many of you or who all gave the title as London? Please unmute and let me know. Okay, so you raised your hand. Okay, that's great. That's great. And you'll be excited to know that the computer has also given the title as London, right? Okay, so apart from this, you can see that the computer rightly infers it from the text. And it is also interesting to see how it extracts some main points from this paragraph. Not all the points are written, not exactly the entire paragraph has been copied by the computer, but few of the main points has been extracted. So how many of you summarize the same points? I'd like some of you to unmute and tell me whether you have summarized the same points or you have added something else or left out something.
Ma'am, can I tell?
Yes, go on, go on.
Yes, ma'am. Ma'am, I have written London is the capital of the United Kingdom, and I have written it lie on the Great Lake River Thames in the southeast of the island of Great Britain, and I have written London's ancient core is the city of London largely retains its 1.12 square mile medieval boundaries.
Okay, that is
Ma'am,
great. So,
I
yes,
have
go
also
ahead, go ahead.
written like
May I tell?
ma'am, London. I have also written that London is a major settlement, ma'am, for millennia means ma'am 1,000 years. So it has been a major settlement for 2,000 years.
Okay, great. Anything else? Any add-ups? More add-ups? So all these points are not summarized by the computer. Yes, tell me, go ahead.
Ma'am, I have summarized in a way that London is the capital of United Kingdom and the most populous city of England, and it is on the side of the river Thames, and it was founded by the Romans. That's it.
Okay. Okay,
Yes,
that is great. Yeah, go ahead.
ma'am, I have given a title that Beauty of United Kingdom, and ma'am, I have added a point that London is a famous city and it is very popular for its buildings also.
Okay, great.
The
So,
clock tower is there only.
okay, that is great. That is great. So your title was something more attractive, right? You had given another adjective to it, say beauty of London, which the computer has not done, right? So, okay, that is a nice thing to know. Anything else? Any other titles maybe? If you've summarized some other title?
Ma'am, I have given the title The City of London.
the famous capital of United Kingdom.
Okay, that is
Ma'am,
great.
I have
That is great.
written,
Yes, go ahead.
ma'am, the culture of London.
Okay, the culture of London. All right. So, as you can see that you all have done better than the computer, but the computer has done a decent job, right? Okay. So, we can give that to the computer. All right. Yeah, moving on. So, okay, here's a question for you. Do you think NLP or natural language processing is difficult? How many of you think NLP is something difficult to do? Okay, a lot of you have raised your hands. So I'd like some of you to unmute and tell me why you think it is a difficult thing to do. So maybe Nitya can go ahead. Okay, anyone else? Anyone can go ahead.
May
I can.
Yeah, go ahead. Go ahead. Whoever's speaking, go ahead.
It is
the
very
language
difficult
we
because
use
you
is
have to
something which
translate
comes
the
naturally to us.
normal.
And I think it
One
Easy
at a
thing.
time,
And
please. One at a time. Yes, yes. Okay. Okay.
Ma'am, can I tell?
Yeah, go ahead.
Ma'am, NLP is difficult as it's the nature of the human language that makes NLP difficult, and the rules that dictate the passing of information using natural language are not easy for the computers to understand.
Absolutely, absolutely. Well put up. Anything else? Any other points that you
No,
think?
ma'am.
Okay, and someone else? Anyone else? Um, yeah, go ahead, someone.
yeah, because we have to make algorithms or we have to write code according to translate the human language to something that the computers would understand. That would require a lot of effort, etc. So I guess that's why it is difficult.
Correct, absolutely. So you need to make computers more like you, right? More like you, the way you understand text, the way you understand language. You have to make the computer do it, and that is a very difficult thing to do. All right. So I think maybe some of you have some experience with programming. So you might have noticed that even making computers do simple tasks like maybe calculating some simple thing, making a pattern or something, is also requires a bit of lines of code, right? So understanding language is even more
मैम
difficult. Anything else? Yes, go ahead. Go ahead.
मैम 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 एलएलपी क्या होता है मैम?
एनएलपी का फुल फॉर्म नेचुरल लैंग्वेज प्रोसेसिंग है.
ओके
ठीक है.
मैम.
ठीक है.
ओके.
तो जैसे मैंने प्रीवियस स्लाइड में बोला था कि एनएलपी से हम क्या करते हैं कि एक कंप्यूटर को टेक्स्ट, जैसे हम लैंग्वेज को समझते हैं, हम कंप्यूटर से भी एक्सपेक्ट करते हैं कि वो भी हमारे लैंग्वेज को समझे. ठीक है. Okay. Yeah. So coming back to the question about why NLP is difficult. Yeah. So I've got many answers right now. So I will continue. So some of you might still be wondering why this is an entirely different branch of artificial intelligence and why is it so important and challenging. So it turns out that NLP is one of the most challenging areas of artificial intelligence. As someone rightly pointed out, that human language is very complex, right? So language mainly has three parts to it: syntax or grammar, semantics or word meaning, and morphology or tense. So to converse with us humans, a computer must be aware of all these things, right? So any other difficulties that you can think of? Any other, like I talked about these all things like grammar, word meaning, tense. Anything else that you think that is complicated in a language? Like something you might have also faced in your um, English and stuff.
Vocabulary, ma'am.
Vocabulary. Yes, that is the same as, almost similar to word meaning. Yes, correct.
Sense
Anything
of
else? Yes, go ahead.
ma'am, sense of humor.
Sense of humor. Okay, that is an interesting point. So understanding sense of humor or sarcastic remarks is also difficult. Yes, of course.
Ma'am,
I agree. Anything
Ma'am,
else? Yes, yes, go ahead.
Ma'am, may I tell?
Yes, go ahead.
Ma'am, opposites and similars, synonyms and synonyms
Okay, yes,
and antonyms.
that is correct. So a particular word, many words can have the same meaning, right? So that is also difficult. Correct. Anything else? Synonyms and antonyms, absolutely. Anything else?
Ma'am, spellings.
Spellings, yes, of course.
ma'am,
But
can I tell one?
yes, go ahead.
Yes, ma'am. Ma'am, it's difficult to like understand the modeling of the elements within a variable text in NLP.
What do you exactly mean by variable elements here?
Ma'am, like if we assign a variable, so like if we don't assign it correctly, so the computer wouldn't recognize it like a thing like that.
Okay, okay, makes sense. Anything else? Yeah. Anyone can go ahead? Yes, go ahead.
Ma'am, figure of speech.
Figures of speech. Absolutely, absolutely. Figures of speech is also an important part of language, which will be hard to model in NLP. All right, now we can continue. So you all talked about various difficulties. I'll talk about two of them. I think some of you have already pointed out, but I'll still go ahead. So we often come across same words in sentences that have completely different meanings in different contexts. Like say these two. So where are you heading and where are you from? So these two are completely different questions, but where are you are similar in both of them, right? All right, now let's look at this. There are two sentences. What is your age and how old are you? Both of these sentences mean the same thing, but these are modeled as completely different sentences, right? Even though the end meaning of these sentences are same, but they are different when you look at it, when the computer processes it. So this is another difficulty. And the meaning of the word, as you can see here, is often determined largely by in which context it has been used. So I'd like you all to see this example and focus on the word bank. Okay, so the first sentence is we went to the river bank, and the second sentence is I need to go to the bank to make a deposit, right? So someone can come up and tell me whether these two sentences, in these two sentences, bank have the same meaning or different meaning. Yeah, someone can unmute.
Ma'am, they have different meaning, ma'am.
Different meaning. And how did you find out this?
Ma'am, a river bank means the shore of the river, and
Correct.
and the bank means where money we can deposit money, we can borrow
Correct,
money.
correct, absolutely correct. So we found out this by seeing not just the word bank, but the sentence, the rest of the sentence in which the word bank has been used, right? Okay, great, great, great,
Yes, ma'am.
great. Okay, so now I'll talk about one last challenge. Okay, so the computer understands everything in binary representation. Now, anyone here knows what binary representation means? Anyone can unmute and tell me?
Ma'am, all in ones and zeros.
Yes, correct. So everything, the computer understands everything, no matter whether it is a language, it is a text document, pictures, everything. Yes, everything in zeros or ones, right? So absolutely correct. You all are very smart and you all know about this. That's amazing to know. So the challenge here is how would you mark meaning of a word in zeros or ones? So at first glance, this might seem like something very difficult to do, almost an impossible task. So can you think of some ways in which we can do this? And this is quite a difficult question, and we'll see the end. We'll see the answer at the end of this presentation. So any guesses? Any random ideas? You can let me know.
Ma'am, can I tell?
Yes, go ahead.
Of times you put 0 and 1 might, like, if you put 2 times 1 it makes one letter, and then if you put 3 times 1 it makes another letter or something like that.
Okay, absolutely. So that is used to represent a word, but you want to represent, say there's a word apple. Okay, now apple can have two meanings. One is the fruit and one is the service company, which has iPhones and iPads, right? Now if you represent apple in as a fruit and apple as a company as the same series of zeros and ones, it will be difficult to understand for the computer that which apple is this talking about, right? So now we are talking about meaning. All right, so we'll see this soon. Okay, but that was a good try. Okay, amazing. All right, so let's move ahead. Okay, so now let's see some real life applications of NLP. Most of you will be amazed to know how NLP you use in your daily life without even realizing. All right, so there are many different applications of NLP, and because of the interest of time, we'll speak about a few of them. Starting with one of the easiest applications of NLP, which is spelling check. Okay, so how many of you have made spelling mistakes while typing something out either on Google or while writing an essay in MS Word or while making a presentation? I'm sure a lot of you have done it. Even I have done it many times, right? We've all made spelling
Yes, ma'am.
mistakes.
Yes, ma'am.
Absolutely. Okay, so now can you tell me when you have made a spelling mistake on these things like MS Word, these applications, how do you find out? Is there any way that you find out that you have made a spelling mistake?
Ma'am, can
Ma'am,
I tell?
Ma'am,
Ma'am, can I tell?
there will
Yes,
be a
yes,
red
yes,
line
go
at the
ahead.
bottom.
Ma'am, in
Ma'am,
when
in MS Word, ma'am, when we do a mistake, a spelling mistake, so ma'am, then there is a red underline on that word. So ma'am, we can understand that that word is wrong or not in the word dictionary.
Correct, absolutely. Well done. So most
Ma'am,
of you
may I
have
tell
given the
one?
right answer. Yes, yes, go ahead.
Ma'am, in WhatsApp or something, when we tend to write, so it is being auto corrected by the Google if we have
Yes,
that.
correct, correct, absolutely correct. So here we came across two things while making a spelling check. One is, as you all talked about in MS Word, that it is highlighted in a wavy red pattern, right? And that's how we find out that it is a wrong spelling on our part. Then we double click on it, we select that word, then we find out that what the correct spelling is, right? Then we can correct it easily, right? So this is one of the applications. So here under the hood, NLP is at work. Okay, so this is one of the applications of NLP, and NLP helps to do this. Okay, next let's talk about information extraction. So information extraction is nothing but Google search. So I'm sure a lot of you have used Google to search for a lot of things like games, music, pictures, some academic related answers. So I'd like to know what is the most interesting thing that you found out using Google search. Anything, any experience that you want to share, like something you found out using Google which you were like surprised to know at first? Yeah, some of you can unmute and tell me.
Yes, ma'am. Ma'am, sometimes when we search on Google, so ma'am, sometimes some extra information is also popped out, and ma'am, from that also we can get some shocking facts and ma'am many more things.
Absolutely, absolutely. Amazing. Anything else? Any
Excuse me,
interesting
ma'am.
experience? Yes, go ahead.
Ma'am, I have a doubt.
Yes, go ahead.
Ma'am, some apps are there on PC or mobile that are used to autocorrect the words. So, ma'am, they are also using the NLP.
Yes, autocorrect is also an app like NLP ka application. So autocorrect under the hood of autocorrect, NLP is at work. There is some amount of machine learning also, because if you see that when you're typing on WhatsApp or some of these chatting things applications, then you'll see that some things which you have written earlier, maybe texted to someone, that also appears. So it is more personalized because it uses your previous data, the data history that it has from various chatting platforms, from your Google searches. So it is more personalized to the user, right? And it has both the applications of machine learning and autocorrect. So this is one of the applications of NLP.
Ma'am, you are not audible.
Ma'am, you are not audible.
Yeah, just hold on a second. Yeah, maybe there is an internet issue.
Okay, really sorry about that. There was some technical problem. Yeah, okay. So, anyone remembers what I was talking about?
Ma'am, you were talking about information extraction.
Yes, absolutely. Correct. So I was talking about Google search, information extraction or Google search. So some of you shared your experiences of Google search and how you came across something interesting through it. Yeah, now we can move on and talk about, yeah. Anyone wants to say something?
Ma'am, this is Vashni, ma'am.
Yes, go ahead.
Ma'am, in Google search a new feature came, ma'am. If we want some like if you are not in if you want some information of something without typing, ma'am, we can click a picture of it and we can search for it, ma'am.
Absolutely. So we can, there is a feature of searching by picture, correct? Yes, searching by image that you noticed. Yes, absolutely. So there what is happening is a picture. So the picture is summarized through a text, and the text is again converted to a picture, and you can search for images by the way of it. Amazing. All right. Yeah, so that is something interesting that she shared. Anything else?
Excuse, ma'am, I also have an example.
Yes, go ahead.
Ma'am, there are many platforms of education apps too, like they scan our questions and they provide the solution according to the question we have given them.
Yes, that is also an amazing thing. So there's a picture, and from the picture we can get the solution, because the computer translates that the text written in the picture to a computer understandable text and searches the solution and gives you the solution directly. So that is a very convenient feature, right?
Excuse me,
Amazing.
ma'am.
Yeah, go ahead.
Ma'am, I couldn't quite understand the key-based information retrieval.
Okay, so I haven't really talked about it. So I am just talking about a few of these examples. First, I started with spell check. Then I'm talking about information extraction, right? Information extraction, Google search. So you can always Google about the rest of it. We are, due to the interest of time, we are focusing only on a few of these examples, right? A easy one, a medium one, and a hard one. Okay?
Yes, ma'am.
Okay. Yeah. So anything else, guys? Okay. I think we can move on. So yeah, we talked about Google search. Right. So okay, so great. Now moving on to another application of NLP, which is machine translation. So how many of you are familiar with Google Translate?
Ma'am.
Ma'am, when we
Yes,
translate
ma'am.
Yes,
when we
ma'am. I have
translate
used it many times.
it translates
Yeah.
into another language we like.
Correct, amazing.
We are
So
not
Ma'am,
have
quite
you
able to
sometimes,
understand
ma'am,
particular
sometimes,
language. We
ma'am,
just
one
simply
at a
want
time,
to Google
please?
Translate and translate
ma'am,
it to any
sometimes,
desirable
ma'am,
language.
one.
Ma'am, may I?
Yeah, just go one at a time so that I can hear you. Okay. Yeah, go ahead, Nidhi.
So, ma'am, it translates one language to another. Like nowadays, you can actually scan a language. Like suppose you have gone to a new state or country and you don't know that language, you just scan it and translate into your language so that you can read.
Correct, absolutely. So that is also something very convenient, that you can just scan maybe a board where a particular language is written, and yeah, correct. Amazing. So yeah, so Google Translate is at work in this. Yeah. So have you all, like, I'd like you all to come up with maybe a foreign language that you've, just out of curiosity, you have written maybe a sentence in English or your mother language, and you wanted to convert it into some foreign language. So have you all ever done that?
Yes,
Yes,
ma'am.
ma'am.
Many
Yes,
times.
ma'am.
Yes,
Ma'am, I
Yes,
have
ma'am.
done.
Great. So this is all about machine translation, right? And you might have noticed that this is something very not very accurate, right? Because sometimes there are some mistakes in the computer, and it's not very natural to see about machine translation. So work is still being done on this application to make it better, but NLP is at work in this. All right. So moving on. Okay, so we see some more examples of NLP. We start with sentiment analysis. So, what sentiment analysis is, it is a technique to determine whether a particular comment or something maybe on various shopping platforms is, this is often a textual data, like what kind of sentiment it is portraying, like a positive one or a negative one or a neutral one. So, this is mainly used by businesses to monitor brand and product sentiment and customer feedback. Okay, so now you can see 3 comments on your screen. So I'd like some of you to come up and tell me that why do you think these comments are declared as positive, neutral, or negative? Okay,
Ma'am, can I tell?
Ma'am, may I?
Ma'am, may I tell?
okay, I'll
Ma'am, so
just
that
call
we
out
can
someone.
Ma'am,
Okay,
may I
I'll
tell?
just call out someone. Varshini, go ahead.
Ma'am, like they keep it uh, uh, like what is our experience when we shop in the certain platform? Is it good, or like it is neutral, okay, or it is not so much good?
Yeah,
Ma'am,
so
ma'am, may I tell?
my question here
Yeah.
is, let me just clarify my question once. My question here is, there are three comments here, and you can see below that they are declared as a positive feedback, a negative feedback, or a neutral feedback. So my
ma'am, can
question
I
here is,
comment?
why is it declared as so?
Ma'am,
Because of
may I
the
tell?
Ma'am, ma'am,
Ma'am, may I
Ma'am,
tell?
because it's in a simple
because of
Ma'am,
the
may I
language for the
tell?
computer to
news.
understand.
Ma'am, may I tell?
And because of the experience.
Ma'am, because it's in a simple language
ma'am,
for
the
the computer
words
to
you
understand.
Ma'am, because
tell
of the
how
adjectives that are
Ma'am,
used.
Okay,
because
so
the
now I
words are
can't
the
understand what anyone is saying.
And because
Uh,
of the words used in the sentence.
yes, ma'am.
okay, Ayush,
Yes,
what
right.
were you saying? Can you please repeat it? Go ahead, Ayush.
Ma'am, this is because of the word used in them.
Yeah, like suppose I ask you for positive. So why was it declared positive? Which word declares that it is a positive?
Fantastic.
Ma'am, fantastic.
Fantastic.
Ma'am,
Correct. Amazing,
ma'am,
amazing.
it's
And what about
Alexa
for
is a
neutral?
female.
Okay, I guess.
Okay,
Okay,
Alice.
I guess. Okay, I
Right.
guess.
Okay, okay is the neutral word. And what about for negative?
Ma'am, useless.
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 Useless. Amazing. So the computer is trained, okay, on these kind of positive, like it is trained from previous data about these positive words, these negative words, and these neutral words like fantastic, amazing, all these kind of words. Okay, exciting. All these words are positive words, and useless. Um, s- Other words, other negative words like that, and there are more neutral words like this. So the computer is trained on this data, that if it sees these words in comments or feedbacks, then it declares it as a negative feedback or a positive feedback or a neutral feedback. Okay, so yeah, now I will give you a question. So what if I change this sentence to my, so like I explained before, that these kind of positive words and negative words and neutral words are highlighted by the computer, and it remembers it, and then it sees that okay, so these are the positive words, it is there in this feedback, so let me declare this as a positive review. All right. So now a question for you is, suppose this is my comment, that uh, my experience so far has been not fantastic, has not been fantastic. Okay, so the sentence again is, my experience so far has not been fantastic. So how do you think the computer will deal with this? First of all, tell me whether this is a negative review or a positive review.
Ma'am, it's a negative
Negative
review.
review.
Ma'am,
Yes.
it is a negative
Ma'am,
review,
it's a
and I
negative
Yes,
think
review.
the
yes, correct.
computer will face some
Because of the
difficulty
words
in
used.
classifying this.
Correct, 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 correct. So it is a neutral, sorry, it is not neutral, it is a negative review, right? So, and why do you say that? Yeah. Um, okay. Go ahead, Khushi.
Ma'am, I would say it is a negative because it's your sentence, but my experience has not been great so far. That means it has not been good.
Correct. So it has a not fantastic thing. So not is an important word here. So how do you think a computer will handle this? Like it has seen the word fantastic. It is not having a lot of focus on my experience so far has been and everything, right? So how do you think a computer will deal with it? Okay, I'd like some of you to go ahead. Okay, Roshan, go ahead.
Ma'am,
Yeah,
ma'am,
go ahead. Yeah, tell me.
ma'am, it is trained to identify the feeling, ma'am.
Yeah, it is. But I am asking that suppose the sentence is that my experience has not been fantastic so far. The computer sees the word fantastic in it, so it will declare it as a positive review. But it is wrong. It's supposed to be a negative review because it has the word not in it. Right? So how does a computer deal with it? Any ideas? Alright, so I'll go ahead. Okay, so what the computer does is something similar again, that it keeps track of these negative words like not, none, didn't, and so on. Okay, all these negation words. So it highlights these words and at the end it negates the conclusion as well. Say for example, I take the same example that my experience so far has not been fantastic. The computer highlights the word fantastic because it has seen it in a positive review, and also along with it, it highlights the word not. So not is a negative word, right? So it negates it. Now, if it was only fantastic, the review would have been positive, but since the word not is also highlighted, it will be a negative review. Okay, great. So we understood a little bit about sentiment analysis. Now moving on. Let's talk about summarization. So the technique where a computer program shortens longer text and generates summaries to pass the intended message is known as text summarization, which is an important problem in both machine learning and natural language processing. So one example of a software which uses this is called Intel PPT. You guys can check it out maybe in your free time. So what it does is, given a PDF or a docx file or a text file, it will convert it into a PPT in seconds. Now this is something which is a huge impact application, because I'm sure some of you must be involved in school in making a presentation. So what you do is you go through various websites, various text documents, and try to summarize it and make the PPT, add pictures in it, pictures as well as text, right? But Intel PPT helps to automate this process and do it much faster for you. Okay, so this is another application of NLP which is very important. So summarization is most mainly of two types. Okay, so two types of summarization include extractive summarization and abstractive summarization. Alright, so first let me talk about extractive summarization, as you can see in this animation. So extractive summarization removes some words from the source text which contribute less, right? So as you can see here that it is first trained on a source text and a summary, and then it understands from the source text and the summary that what all words are more important. Like you can see here that took a taxi to is ignored. Okay, night party is ignored. So only the words that are most important in these sentences are extracted. All right, so this is the extractive summary. Next, we talk about another type of summarization technique, which is called abstractive summary. Alright, so abstractive summary, what it does is, it summarizes the main essence of a paragraph, which as you can imagine is a more difficult task to do, even for us humans. So these are the two types of summarization techniques. If you have come across any other applications which automatically summarizes texts, you can let me know. Have you all come across some other summarization techniques? Okay, yeah, all right, so we can move on and discuss this at the end as well. All right, so coming to translation. So I've already talked about this in the previous slide, and here you can see it in action. So this is the English sentence. I don't have money to hire a translator. I wonder if I could use this to translate my book to Hindi. Now this is the Hindi translation of this. मेरे पास, this is on Google Translate by the way. So the translation is, मेरे पास अनुवादक को हायर करने के लिए पैसे नहीं है. मुझे आश्चर्य है कि अगर मैं इसका इस्तेमाल अपनी किताब को हिंदी में अनुवाद करने के लिए कर सकता हूँ. So even though this translation is good, but it is not completely accurate, as you can see. I think most of you can do better than a computer than translating this, right? All right. So okay, so we have seen quite a few examples. Now some of you also talked about autocomplete, and I think I just mentioned about it to one of the students, that autocomplete is more personalized, and it uses your own data as well. So this is also an application of NLP, and I just talked about it, right? I think Bhumika asked about this. Okay, great. Yeah. So the final example is about rephrasing. So are any of you familiar with websites like Grammarly or Ginger, which are grammar check websites?
Yes, ma'am.
Okay, grammar check websites you're aware of. So have you all used it in maybe some of your school tasks and stuff? Which website have you used?
Grammarly.
Okay, great. Even I have used Grammarly a lot. So mainly these kind of websites are used so that we can write proper formal English in formal settings. Okay, so yeah. So this is something which a lot of us use in school, college, and everywhere, right? So I'm happy to see that even you all have used it in your school. So you all can relate to this. This is another application of NLP, right? Okay, so here you can see an example of this as well, which rephrases the sentence into a better sentence, right? Okay, moving on.
So instead of small age, we should write young age.
Yes, in a more formal setting. Yes, so a student just pointed out a rephrase of this sentence, right? And from here, I think you also understood like a more formal English that has been used in this, right? So you can also learn a better English from these kind of websites when you type in some sentence and it converts it into a better English. So yes, as you rightly pointed out, that instead of small age, using young age has a better impact. Okay, great. Let's move on. All right. So now that we have seen a lot of examples of NLP, now is the time to go under the hood and see what goes on in the computation part of these applications. So here's a problem statement for you. Say there's a comment, like say there's a Google search query, like you all talked about. You can see one here, like how should I go to New York? By bus or by car? And your job is to find relevant web pages or answers for this. Any ideas on how Google does this? This is quite a difficult thing to do, right? Yeah, so many of you use Google search, but how it actually works? Yes, go ahead, Daksh.
Yes, ma'am. Ma'am, sometimes ma'am, Google uses the words that are the same words that you type in the Google search are same in some of the websites. So, ma'am, it automatically shows that websites of that, and ma'am, sometimes the people who search this sentence, and after that the results they get, so Google recommends that only to us also.
Okay, great. So Daksh talked about two important
Excuse me,
things.
mom.
Excuse me,
Yes,
ma'am, I had
yes,
a
go
doubt
ahead. Go
in
ahead,
Ma'am, could
Nidhi.
I add
summarization.
something each other side? Could I add something?
Yes, okay. So Nidhi had a doubt. Let her go ahead, and then you can ask.
Ma'am,
You can
actually,
tell
I have a
yours.
doubt in summarization. Can you just tell it again?
Okay, which part? Okay, Nidhi, I think we can come back to this at the end of the presentation. Will that be fine?
Yes, ma'am.
Okay, great, great. Yeah, Aja, go ahead.
Sure. Like when we search for like how should I go to New York with a bus or a car? So mainly when we search, so at the bottom of those links we get that word missing. So if like and they take the main word and they search it, and in the links if they find the same word relevant to that or the same relevant content in that, so they show it. And they also show below those links that missing word. So if the word like let's for example if the word bus is missing, so it would show us that this missing word is bus. So basically from this we could infer that it shows us the relevant things or the relevant links or web pages by just taking the content which we want to search, and they just like it, that's about AI, that how it searches on those links and gets the real content which we need.
Absolutely, Aja. So I think both Aja and Daksh pointed out really
Excuse me,
interesting
ma'am.
things.
Ma'am, I think I'll be able to add one thing as well.
Ma'am, can I
Okay,
add?
go ahead, go ahead, go ahead, go ahead.
That the various images and the various web pages we sent, it classifies it with the machine learning to add tags to it. So when we search this with NLP in the search engine, so it sees the important words with the help of NLP and then sees the same tags and shows us the relevant
Absolutely,
results.
absolutely. So many of you pointed this
Excuse me,
out.
ma'am.
Yeah, I think we can go ahead and then we can come back to your points, right? All right. So the thing that I said is that, yeah, thing that
Ma'am,
most of you talked about is that that there are few words that are in our text, in our search query, and Google kind of matches it with what maybe web pages which have
excuse me,
the
ma'am.
occurrence of these words the most, right? So yeah, this is a very important thing, that it matches the words more relevant to our query. So yeah, moving on. So well done, guys. You all have given the right answer. But let's walk through a pre-step to this. When once you're given a query, it is not processed as it is by the computer. There are a few pre-processing steps before it. So let's have a brief discussion about this. So pre-processing mainly has 5 major steps in it, which is sentence segmentation, tokenization, stop word and punctuation removal, lemitization, and bag of words. So let's walk through it once. So the first is sentence segmentation. So suppose you have a sentence and it has a lot of words in it separated by a space or other punctuation marks, and so those things are breakdown into words. And it is also normalized meaning suppose there are a few capital words in the sentence, those are converted into lower words, right? Okay. Next, there is so that is called normalizing. Next, we move to tokenization. So tokenization is basically generating tokens for the words, which is like a code word for the words, right, in the sentence, and unnecessary information is removed. Next, stop words and punctuation marks are removed. So, what are stop words? These are actually the most common words in any language, like articles, prepositions, a, and the, all these words, right? Which do not add much information to the text. Next, there's lemitization, which uses grammatical rules or stemmers for reducing words to root words. For example, if there is something like runs, running, ran, and all that, so that is converted to run, which is a lemma of these words, right? Next, there's a bag of words model, which is the final representation of any document for further study. Okay, so that was a lot of terms, so don't worry about it as long as you understood the concept. Don't worry about so many terms, right? So we will look at an example to understand better. So this is the sentence, which is Jenna went back to university. Now, what was normalizing? Can someone come up and tell me? I just told about it in the previous sentence. Okay. Yeah, many of you have raised your hands. So I think you all remember. So that's a good thing. So basically, normalizing, the capital letters are changed to small letters. Here you can see Jenna went back to university, J and U are capital. So now these are changed back to small letters. Next, they are tokenized. Tokenized meaning code words. So here the same words are used, but in more complex sentences, different words or maybe even numbers can be used. Right? Here the same words are used, but they are separated with a comma. Right? So these are tokenized. Next, stop words are removed. Now you might have a question that what are these stop words? How will you understand what the stop words are? So these stop words are basically there is a list of data that is already given to the computer, and the computer, this is done by a lot of people that have observed that some words don't really give a lot of value to a sentence. So those words are also removed by the computer. Here back and to are removed by the computer, right? Next, we talk about lemitizing. Lemitizing, as I talked about, that runs, running, ran, all are lemitized to a root word. Now, the root word is run, right? Similarly, for went, the root word is go. And for university, universe can be the root word. So, this is the lemitization process. Now, let us see one more example. I'd like one of you to give me a small, simple sentence. So then we can move ahead with it and follow the same steps. Yeah, so anyone can volunteer and they have to go through the same steps with me. No, I just need something. I think Ritisha Das can go ahead. Ritisha Das, you can go ahead. Okay, okay, Nidhi, you can go ahead.
Yes, ma'am. Like I ate an ice cream is the sentence.
Okay, I ate an ice cream. Now I'm assuming I here is capital, alright?
Yes.
So when I normalize it, what will happen? I will become small,
Yes.
right? I ate an apple, alright. Now we want to tokenize it. Now tokenization, what will happen? I, instead of Jenna, went back to university. In these two quotes, there'll be I, there'll be an 8 and apple, right? Okay. Now tell me what the stop words are in I ate an apple.
An.
And absolutely. Very good. Very good. And anything else?
Ma'am, and
I can also be a stop word. Absolutely. Okay, great. So I and an will be removed here. Now there is 8 apple. So both are basically the root words. So nothing will be removed. Right? So when we stem or lematize it, there will be only 8 and apple. Correct? Okay, great, great. Good job, guys.
ma'am, when we lematize it, it will become 8 will become 8, ma'am.
Yes, correct, correct. Very well pointed out by who was that? Harshini?
Ma'am, Harshini, ma'am. Yes, ma'am.
Yeah, very good, Harshini. So, as she rightly said, that 8 will be replaced with eat. That is absolutely the right answer. Very good. All right, moving on. Great. Now we are done with the most important pre-processing step. Okay. Now coming back to your answers, I think a lot of you said that the words that we search for, those are matched with the documents that are available on the internet. So the term for this is term frequency. All right. So term frequency is the number of times each word occurs in a document. Right, so here we can see an example. Suppose I talk about a word like complexity and I have total, suppose in the internet at some old time there were only 5 documents and I have to see that how many times complexity occurs in these documents. So I make a frequency chart of this. So complexity occurs 2 times here, 3 times in document 3, 2 in document 4 and 3 times in document 5. Right? So similarly, a matrix for all these terms are made. Now suppose I search for a word like network. Okay, I just search for what is network. Now what will Google suggest me? Which document will Google suggest me? Please see this image and let me know. Which document will Google suggest?
Ma'am, document 3 one.
Very good. Document 3. Absolutely. Very good answer. So document 3 is the right answer for this. Because network occurs 4 times in document 3. Now, coming to the drawback. So, do you think that this has any drawback? Can there be any mistakes in this? Think of these queries. Okay, suppose the query is the definition of carpenter is, the meaning of ambivalent is. These are my queries, and here the 3 common words that are used is the, of, is. So how many times do you think the, of, is will occur in a document compared to carpenter? More or less? More. Absolutely. It will occur more number of times. Why? Because the, of, is are very common words. But what about carpenter? It will occur less number of times. Right? Okay.
Yes, ma'am.
So, but what do you think should be the what do you think should be the main main word for this query? Should it be the, of?
Definition and carpenter.
Definition and carpenter. But what about their occurrences? Will they be less or more? They will be less. So will it be
Less.
beneficial for our search? When we search for it, we will get documents where the, of, is has occurred more number of times. So the weightage given to carpenter will be less compared to the, of, is, which is not the right thing to do, right?
Yes, ma'am.
Yes. So I hope this is clear to all that there is a major disadvantage with this method. So let us see whether we can improve on this. Now we come across another term, which is inverse document frequency. So suppose I have say 10 documents and I have occurrences of various words, okay, in that document. Then I calculate the inverse document frequency, right, where I divide the document frequency by the total number of documents and give it a number. Now how is this useful? Let us see an example. So remember the previous queries, the definition of carpenter is. Now say I have total 10 documents and the occurs 20 times in these documents. So what will be the IDF of the? IDF meaning inverse document frequency. So what will be the IDF?
Ma'am,
Yes, go ahead.
ma'am,
Kind
I
of
had
want
a
to.
query that in the previous slide you said that what is the meaning, that mean the definition of carpenter is.
Yes.
But as we read previously that the stopwords will be removed from the queries, Google will take only 2 words, definition and carpenter.
Definition and carpenter. Yeah, that is right. But while processing, maybe like based on our training data, maybe the may not be removed, or it really depends. Like it might be possible that the pre-processing steps are not done, or maybe they are not done more accurately. So we don't want to take any chances. Also maybe leave this example. Say we talk about another example where these stop words are not there, but some common words are there. Say the national bird, the national bird of India. All right. So bird, which is more common, bird or India?
Bird.
Bird. But
Yes, ma'am.
am I more
Bird.
interested in bird or national and India? Am I more
National
interested?
India.
National and
National,
India.
bird, and India. Correct. India is more important. Now, if I search for bird, if Google focuses more on bird, then I will get various pictures of birds, which I'm not interested in. What am I interested in? Bird and India, right? Which has to be a peacock. So this will narrow down. So I think this is clear now that it might not be the stop words, but any common word, right? Is it clear?
Yes, ma'am. Thank you.
Okay, okay,
Yes.
great. Okay, so coming back to the question that what is the inverse document frequency of the in this? So as you can see in the formula that total number of documents is 10 and the document frequency is 20. So the IDF for the will be 10 by 20, which is 0.5, right?
Yes.
And for carpenter it will be 10 by 5, which is 2. So which is given more importance, carpenter or the? So this was 10 by 5 2 and there was 10 by 20 0.5. So which is more? Yes. Carpenter.
Carpenter.
Absolutely. So this is what our problem was. In the previous slide, this is what our problem was and we correctly solved the problem here. Right? Okay, great. Now, this method still has a disadvantage. So say the word apple, as I talked about previously. Now, apple can have various meanings, right? So is this inverse document frequency capturing the meaning of words? So the answer is no. So we have to find out some other technique which embeds meaning in some way, right? So this is the major discovery finally of NLP, that is word embeddings. The technique used to represent words as vectors. So does anyone here know what a vector is? Any ideas about what a vector is?
Illustrated painting.
Just a minute. Yeah, what is a vector?
Illustrated painting. Digital illustration.
Okay, digital art. Okay, that is okay. So here is an example of a word with multiple meanings, right? Vector can also have this meaning. It can also have another meaning with magnitude and direction, right? A thing which has a magnitude and direction. I think some of you have read about it. But here we'll just refer to vectors as a collection of numbers. Okay. So let us look at an example. Say cat. So cat here, as you can see, there are various numbers written. Now all these numbers refer to a particular property like living being. Living being has high weightage because cat is a living being. Now feline, cat is more towards feline than a living being, so it has 0.9. Now human, cat and human have no relation, right? So it is 0.1. So all these weightages are given between -1 and 1. Now let us look at another example. Say houses. Now houses is plural, so it is given high weightage here. Right? So I think you kind of understand what is going on here. Right? So word embedding learns these weights on its own. Okay, it learns these factors by itself. Now this is a very important thing because it captures meanings, relationships between words very well. Now I will give you an analogy question. Okay, say man is to woman, then boy will be is to
Girl.
Girl.
absolutely correct. Just a minute. Yeah, boy will be is to girl, correct. And tiger will be is to
Tigress.
tigress. Correct. So you will be astonished to know that these kind of relationships between man and woman, king, queen, all of these are captured by this word embeddings, which which IDF was not at all able to do. Right? And it learns all these factors by itself, which is also an interesting thing to note. Alright, so word embeddings is very important. Now we have talked about all these methods of pre-processing, processing, word embeddings to solve a wide variety of tasks in NLP. So can you tell me some examples now that we have talked about so many things?
Auto correction of words, word search.
Auto correction, very good. More examples? Autocomplete, very good. Anything else?
Rephrase.
Rephrasing. Anything that I have
Ma'am,
not talked about?
sentiment analysis.
Sentiment analysis. Very good. Anything else?
Ma'am, pre-processing step.
Summarization.
Pre-processing steps is not an application. That is what is done. Okay.
Okay.
For the translation. Very good. Anything that you can come up on your own now that I have not talked about? Some application that you can think of on your own.
Scan.
Yes, go ahead.
Google Lens.
Google Lens. Yes, that is also
Ma'am,
an
for
interesting thing.
scanning things.
Okay.
Filtering.
Filtering. Okay. Okay. Spam filtering. Okay. That is amazing. All right, great. So these are Grammarly, very good, very good. So you all came up with interesting examples. So let's see some more on our screen right now. There's part of speech tagging, tagging as in what a particular word is, like a pronoun or a verb or a adjective, noun, all that. Okay. Then we have grammar check. Someone just talked about Grammarly. Then we have text summarization. Okay. And then we have this machine translation. And we also have Alexa, right? Like people talked about before, right? Okay.
Yes,
Great.
ma'am.
Great,
Ma'am,
great, great. Yes.
NLP can NLP also be used in coding, because as we learned previously that a machine understands everything by 0 and 1, that is the
Yes.
binary digits.
Mm-hmm.
So whatever we write would be done in NLP.
Okay, so you are saying that I will write something, a sentence on my own, and it will be completely changed to a code, right? Is that what you're talking about?
Yes, so computer understands it in 1 and 0.
Yes.
But what I write, that is parts of speech, a
Yes.
computer NLP would be applicable there or not?
Yeah, it can be applicable there. You can always search it up, but yes, I think it can be applicable in those situations as well. Okay.
Okay, okay, ma'am.
Okay,
Thank you.
great. Yeah, so okay, so we've looked at a lot of examples now. Okay, so now that we have seen a plethora of applications of NLP, it is interesting to note that there still exists a lot of unsolved problems in this domain. Now that you have a fair amount of idea about what NLP means, you can explore these different areas and challenges of NLP and dive into this area which has a huge impact on the daily lives of millions of people. Right? So hope you all have taken away something from this workshop, and all the best to you, and see you in future workshops. Any questions that you have, we can take it up right now.
Thank you, ma'am, and have a nice day.
Thank you. Have a nice day. Okay. Yeah, I think
So yeah,
Nidhi and Bhumika.
raise
Yeah.
hand one by one. You can.
Okay. On my screen, I can see Nidhi and Bhumika have a doubt. So I think we can disable their, enable their mics so they can ask.
Yes, ma'am. Ma'am, actually, I had the doubt in summarization. Can you just
Yes.
repeat
Go
again?
ahead. Go ahead. Yes. I will go to that slide. Okay. Yes. Tell me about your doubt.
Like, ma'am, I had a doubt. What is summarization?
Yeah, so summarization, basically you have a text. Okay, you have, and this is showing just two lines, but we can have an entire document, right? An entire maybe two or three paragraphs, and we want to summarize it so that it is easy to understand, and we want to capture the entire thing in a shorter sentence. Okay, we want to know the whatever is written in the document, but in shorter sentences. We don't want to read so much, but we want to know what is written in it. So that is when summarization comes into play.
Okay, ma'am. Thank you, ma'am.
Okay. Yeah. Okay. Great. Um. Okay. I think we can take up.
Ma'am, my
Yeah.
doubt was,
Yes. Go ahead.
ma'am, is NLP also used in spam detection?
Yes, NLP can be used in spam detection, as I explained that these words that come up in sentiment analysis, like these positive words, negative words, neutral words. In spam detection also, NLP can recognize these different kinds of words that are used in spam emails. If it is trained on enough data, it can recognize these different things that sometimes in spam emails you might have noticed that there are words which have both capital and small letters, something like that. So it can recognize those kind of words and say that okay, so this has this kind of a word. It will highlight it and put it as a spam. Right? So you're absolutely correct.
Okay, ma'am.
It can detect spam as well. All right, guys.